linear inequality in one variable. A cannot be 0. So it's just showing you that these are inequalities because of these signs here. Your greater than, less than, less than, equal to, greater than, equal to signs. I remember teaching this lesson several years ago. Oh man, did I struggle. And so I totally understand when people don't get it the first time. But I learned it in a way that hopefully it helps you rather quickly. All right, so there's going to be three ways, to show your answer. Okay, so please make sure you write these down on a graph, a set notation, interval notation. Okay. All right, so here we go. First, we have x is less than or equal to -1. And so we're going to write this on a graph. So the graph is going to be pretty basic. The middle number is -1. The number to the left is going to be -2. The number to the right is 0. And this is a less than or equal to sign. It's going to be a shaded circle. Shaded circle. Is -2 less than -1? Every number to the left of a number is less than. So this is the direction of the graph. The direction is to the left. The set notation is going to be, what's the best way to put it for you? The set notation are these, man, I always forget what these are called. I call them wings, but I know that's not what they're called. It's on my thought, and I can't remember it. So x is the variable. This x represent all numbers and infinity numbers. This is such that, okay, this is a set of all the values. This is such that, and then you just rewrite the expression, okay? And that's your set notation. Okay, this is your set notation. This is your graph. It's supposed to be 2 right there. And then your interval notation. Your interval notation is, let's say you have parentheses, and this arrow is going directly towards the infinity. So it's -infinity, -infinity, and -1, okay? And we're going to have a bracket, all right? So let me explain. Every time there's an infinity sign, there will be a parentheses. Or better yet, there will always be a parentheses unless there is, this is a bracket because it's including the -1. And the reason why it's including the -1 is because of the less than or equal to sign. The greater than or equal to sign also has the bracket. Okay. Okay, the next problem. T is greater than 4. T is greater than 4. We're going to do a graph. 4 is in the middle. To the left is less. To the right is 5. It's greater than, so it's an open circle. 3 is greater than 4. No, 5 is greater than 4. So that's my graph. Then I usually do the interval notation. Interval notation second, because I can just start from the graph. The graph, that's a parentheses, is going to be 4, comma, and then it's going into the positive infinity, and it's going to be parentheses. So that's my interval notation. Then my set notation, I think it's a caret, I can't remember what it's called. So T such that, all numbers such that T is greater than 4. All right, and that is your set notation. So I am showing you that because we're going to solve problems now, and they're going to be solving inequalities. All right, and you need to understand that information. All right. So if we have y minus 8 is greater than or equal to -5, we're going to solve it just as if it were an equation. The process is the same. We are doing the addition property of equality. Y is greater than or equal to, in this case, 3, right? So this is our inequality. We solved it. Then we're going to do our graph. Okay, our graph, that's 3. We're going to have a closed circle. Our number here is to the left is 2, to the right is 4. The numbers have to be greater than 3, so the numbers are going to the right. All right, so then we have a bracket. The only time we use a bracket is if it's a greater than, equal to, or a less than, equal to sign. Bracket greater than or equal to 3, and all the rest of the numbers, and so it's a parentheses. Okay, then we're going to do the set notation. We have, man, I struggle still, man. I need to practice on these, really. I still don't get it. Yeah, I struggle. So this is y such that y is greater than or equal to 3. And that's your set notation. All right. Okay. What I need you to understand is this. Very important. If you divide, matter of fact, I think that me solving it is going to make more sense. Okay? I think solving it is going to make more sense. So I have a problem. Of course, you probably didn't see that I have a problem, but here is a math problem. All right, I am going to solve for W. I am going to divide both sides by -5. Okay, because I'm dividing by a negative coefficient. I'm dividing by a negative coefficient, and it's an inequality. I have to change the symbol. I go W is greater than or equal to. Now it says less than or equal to, but I have to put greater than or equal to -4. Then I began my quest to write my work. Okay, this is going to be -4. This is -5, and this is -3. They're negative, so you have to make sure you write it correctly. All right, and then it's a greater than or equal to sign, right? So it's a shaded circle, and the number that is greater is -3. Right, then we're going to do a bracket, -4, and positive infinity numbers, right? And then you have the set notation. The set notation, W such that W is greater than or equal to -4, and there's your answer. Okay. Now, if you see, if I looked at this, 5W less than or equal to negative 20, you would say, oh, there's a negative. No, we're not dividing by negative. It's about dividing by a negative coefficient. This is not a coefficient. This is just an integer. So this is W equals, I'm sorry, not equals, is less than or equal to negative 4. All right. So, and if you plug it back in, you can see that it's satisfied. So negative 4 times negative 5 would equal positive 20. Positive 20 is less than or equal to 20. If I kept it the same, if I kept it the same, or a matter of fact, if I did this, if I said negative 5, if I didn't change this, this is like negative 5 times negative 5 is greater than, let's put it like this. If I kept it like this, negative 5 is less than or equal to negative 4. Negative 5 is less than, but if I put it here, negative 5 times negative 5 would be positive 25, and 25 is not less than 20. So that's why you got to make sure that you change it. Okay. And the interval information is here. Negative 4, negative 5, negative 3, closed circle to the left, right? This is going to be a bracket, negative 4, negative infinity, parentheses, W such that W is less than or equal to negative 4. Okay. Questions. All right. So that is the basics. All right. So I am going to do another problem. Okay. The process is the same. Focus on what the process is. Okay. People don't like processes. I get it. But there is always a process to learning. Plus 11 less than 2 d plus 3. All right. So process is still the same as if this was an equation. All right. Solving in parentheses, none. Exponents, none. Multiplication, you have to distribute. So this is 20 minus 8d plus 11 is less than 2d plus 6. We combine like terms. That's 31 minus 8d less than 2d plus 6. We're going to add 8d to both sides. End up with 31 is less than 10d plus 6. Subtract 6 from both sides. That's 25 is less than 10d, right? Divide both sides by 10. We're going to end up with, I'm going to do the rest of my work. End up with d equals d, sorry, it's 2.5 d. Okay, so we're going to, also could be a fraction, which is 5 halves. This is 2, this is 3, open parentheses. Notice that where this variable is, this variable is on the right side. This is the d has to be greater. All right, so 3 is greater than 2.5. Open circle, so parentheses, 2.5, comma, positive infinity. Parentheses and parentheses. We go with the the set notation. Okay, set notation. D such that 2.5 is less than D. There's your answer. And yes, it could have been written the other way. Well, let me say this. D as interchangeable. Means the same thing. All right, so moving on to compound inequality. Compound inequality. All right, like a compound word, two words put together. This is going to be two inequalities put together. Like, for example, -2 less than or equal to x less than equal to 3. Like, if that was the answer, we would simply graph it. Here's -2. Here's 3. Of course, we had -3 over here, -1. That's how you want to do it. Including -2, draw a line, include -3. Okay, that would be our graph. Okay, that would be our graph. Then we would have our, what's the word I'm looking for? Interval notation. And then, I really don't like rewriting this, but we have to, so x such that -2 less than or equal to x less than or equal to 3. Okay. Graph, interval notation, set notation. So -5 b plus 4 less than 1. So to solve this, we can kill two birds with one stone. We're going to subtract 4 from all sides, on all three sides, right? Okay. So that cancels out. We're left with b. This is -9. It's less than b, which is less than -3. All right. We will. Right. We cannot flip the inequalities because we did not multiply or divide by a negative coefficient. So then we can do our number line. It's -9, -3. Let's say B or all the numbers that's going to be in the middle. So this is going to be an open circle. Open circle. Okay. -9, -3. Okay. And that line draws across. That's our graph. Then we have our set our interval notation. It is saying these are the answers to satisfy this inequality. And just for time's sake, and this would be our set notation. This is our solution set. No, that's not right. That's our interval notation. I guess it still could be considered your solution set. All right, so now we're going to use fractions to solve our problems. And remember how to eliminate fractions. We're going to take the greatest common factor, which is 6. Okay, so we got 6. We're going to distribute the 6 to all the fractions that are not in parentheses. Okay, so 6 times negative 7/3 is really like negative 42 over 13, which is negative 14, I believe, because 6 divided by 3 is 2. 2 times negative 7 is negative 14. Half of 6 is 3. 6 divided by negative 3 is 2. And half of 6 is 3. So here we have our information of an inequality that we're going to solve. So we're going to add 2 to all sides because we have to get the variable by itself. This is negative 12, 3y plus 5. We're going to divide all sides by 3. This is negative 4 greater than or equal to 5 over 3. Okay, so here is our, what's the word I'm looking for? Our graph. Negative 4, 5 over 3 is going to be an open circle, closed circle. Get that line together right there. Okay. Then we can utilize that information to write right here. I can write our set notation. So that's y. It's so funny because I mean I struggle with that. Sometimes I get it, sometimes I don't. So then I'm going to write my interval notation. My interval notation is simply parentheses negative 4 comma 5 over 3 bracket because it's a closed circle, and that's how you solve your problem. All right, then we're almost finished. We're going to start with, hopefully I have enough room, 11 less than negative 3x plus 2 less than 17. So this really I want you to focus. I'm telling you now that I want you to focus and see what that coefficient is. The coefficient is a negative 3, so you know that we're going to do something with these inequalities. Okay. And they want us to write the solution set and the interval notation. So we're going to subtract 2 from both sides. That gives us 15. That gives us 9. We're going to divide both sides by negative 3. So that means that we have to flip the sign. Flip, flip, flip the signs. Flip mode. Okay? And so now we're going to write our number line. Now, our number lines are going to look a little different. Okay? Because we can also write it like this, because negative 5 is less than. Okay, so I just flipped it because this would be a better looking number line. Okay, so you have an open circle, and so my answer is in between negative 5 and negative 3. Okay, And so hopefully you would know that answer, but if you don't, it's okay. But there are many numbers because it could be decimals. So I don't want to throw you off like that. So this is our graph. Okay. That's our graph. This is our set notation. Remember we got X. That's our set notation. And then we use a parentheses for -5. And you got to write it in least to greatest. And so both have parentheses because they both have open circles. All right. Almost finished. This is our last problem. We have a word problem that we're going to use. Last problem for this particular section. Man, I'm proud of y'all if y'all watched this all the way through. For sure. Because I know how videos are. Like if it's not worth my time, I'm not gonna watch it. Okay? The inequalities for at least. At most. Okay, let me do this. Okay, no less than is also this. At most. No more than. Okay, so with that being said, I have to give you this equation. I'm going to kind of read it to you. So you have Joe had a son's birthday party. Okay. The party costs $175 for the first 10 kids. Plus $3.50 each additional kid or child. His budget is $200. Can't spend any more. At most, $200. Spends at most $200. How many children are invited? How many children can make it? Can go. All right? So here's our equation. What we know is he can't spend any more than $200. So at most $200. So the amount to the left can be less than or equal to 200. So $175 plus $3.50 each additional kid, right? So we know the first 200 of that, the first 175 of that is going to the first 10 kids. We know that, right? So that's $3.50 times, $3.50 times something can't be more than $25. So So we're going to divide both sides by $3.50. So how many children? So 25. So 25 divided by 3.5 equals like 7.14. But that's only 7 kids, right? So you got 10 kids plus these 7, so 17 children can go. Or kids. People don't like saying kids because that's baby goats. And so here you have all of this information. I really hope that it was helpful for you. Please let me know what it is that I'm not doing correctly, if I'm not speaking loud enough, and if I'm not enunciating, whatever the case may be. Once again, I appreciate you and appreciate your time for tuning in to Mr. Glenn and driving math. As well, don't forget to subscribe, to share, to like, and put a comment down. And also click on that notification. All right. Thank you. Have a good day. Peace.